So far, we have discovered this wonderful thing called the definite integral can be used to find area under a curve like this. We got this f of x, and we want to get the area under this curve and below the x-axis. We can just integrate, and we can get the exact area under the curve. But now we want to build on that, and we want to consider what would happen if we had another function here, g of x, and we have bounds x equals a to x equals b. What happens if we want to calculate the area bounded in this region? Everything below the f of x, everything above the g of x, between x equals a and x equals b. So that's what we want to do. Now, let's consider just the integral from a to b of f of x. Well, what we would get if we integrate it that way, we would get, as we said earlier, all of this area under the curve. But remember, we don't want all that area. We want just the area bounded above the g of x and below the f of x. Well, let's consider what would happen if we subtracted off the integral from a to b of g of x. Now, remember, the integral from a to b of g of x would be the area under the g of x. In other words, we would lose that area. See? Because we're subtracting it off. See? That is the integral from a to b of g of x. That, if we take the big integral, the big area right here, and subtract off the little bit, we get the area bounded here. That's the area that we want. So it's a matter of taking the function on top, f of x, and subtracting off the integral for the function on the bottom. So this is kind of a formula we could use. Now let's look at an example. Let's suppose we have the function f of x equals x and g of x equals x squared. And what we want to do is we want to find the area bounded between those two. In other words, we want to find this right here. See, here's f of x equals x, and here's g of x equals x squared. We want to find this bounded area. Well, I graphed it, and I can see the function on top is f of x. The function on bottom is g of x. So what we're going to do is we're going to integrate f of x minus g of x from this point right here to this point right here. Now I've got to figure out what those points are. In other words, I need to figure out what the intersection, what the two intersections are. I can do that by setting the functions equal. X squared equals x. Now just bring over the x, factor out the x, just like we did in college algebra long ago, and we get that x equals 0 or x equals 1. So x equals 0, x equals 1, and we get our two intersection points, and now we can set up our integral. The integral from 0 to 1 of x minus x squared, and now we just integrate. We find the antiderivative. The antiderivative is 1/2 x squared. That's the antiderivative of x. And then 1/3 x cubed. That's the antiderivative for x squared. Evaluate it from 0 to 1 using the fundamental theorem of calculus, and we get 1/6. Cool. Okay, now let's look at another example real quick. Let's suppose that f of x is equal to the square root of x, g of x is equal to x squared. Same thing. So we go through the same process. We're just looking at another example here. I set the two functions equal and solve it. I square both sides to get rid of that radical. And I solve it exactly the same way. I solve by factoring, and once again we find that x equals 0 or x equals 1. And those are our two intersection points. Once again, we have the top function minus the bottom function. Find the antiderivative. There it is. Just using the fundamental theorem of calculus, we plug in the 1 and then plug in the 0. Plug in the 1, subtract, plugging in the 0. And we get 1/3. There you have it. That is how we can find these bounded areas like this. Now let's consider what would happen if we had the graphs below the x-axis. Notice over here our graphs were all above the x-axis, and we took the top function minus the bottom function. Now here's what's going to happen. We're going to do the exact thing here. Notice in this one we've got a top function, right? This function is definitely over this function, right? So we're going to take the top function minus the bottom. We're going to integrate it. Now these functions happen to be f of x equals negative x squared. That's this one right here. And g of x equals negative square root of x. That's this one here. And you can clearly see that the top function is negative x squared. So let's do this. Let's find out what the integral is from 0 to 1 of negative x squared. Now I went ahead and factored out the negative here. But what you get then is you get negative 1/3. So what we're saying is this function right here, when I integrate it from 0 to 1, I got this bounded area up here is 1/3, so negative 1/3 because the graph is below the axis. So this right here is the negative 1/3. Okay, that's the top function. That's when we integrated the top function. We got negative 1/3. Now let's go ahead and go with the g of x. And I integrate that, and I get negative 2/3. See? So this negative 2/3 represents, if you look at this bottom function and you integrate it, this area up here is 2/3. Because it's below the axis, it's negative 2/3. Now, notice if we do this, if we take this top function, which is right here, minus the bottom function, see? The top function minus the bottom, look what happens. We get the negative 1/3. Well, 1/3, this, notice, in absolute value is less than this in absolute value. So what happens is, dig what happens here. You've got negative 1/3 minus, using the fundamental theorem of calculus, a negative 2/3. See, we use the fundamental theorem of calculus up here, use the fundamental theorem of calculus here, and now we got this minus this, see, negative 1/3 minus a negative 2/3. Well, that's negative 1/3 plus 2/3. So what we're doing then is a subtraction. We've got the positive 2/3 minus the 1/3, and it gives us the area that we want. And certainly, when you're talking about area, you want it to turn out to be positive. So notice, the top area is here, only it's the opposite. The bottom is here. But when we subtract, when we take f of x, the antiderivative of f of x, this minus this one, we get this.